Hello and welcome to the 2019 HERS Radar Training Code Update course. Completion of this online training course will fulfill the requirements to obtain your 2019 HERS certification for residential new construction, residential alterations and additions, and non-residential. Only the certifications that you currently hold will be updated. Should you want to obtain additional certifications, please go to cheers.org/training or give us a call and we'd be more than happy to discuss your options. The following reference materials were used in the creation of this training. First, we have the 2019 Building Energy Efficiency Standards. Now this document is the overall original code. This is what everything else is built off of. It can be a little difficult to read, but this is where you want to go. This is kind of the source of all the other documents. Next, we have the residential and non-residential compliance manuals. These are essentially an explanation of the standards. These are in more layman's terms, much easier to understand. So these are a good read to get an understanding of what the code is trying to do. Provides a lot more explanations into the various features and requirements of the standards themselves. And last, we have the reference appendices. Specifically, we used sections RA3 and NA2. This is where you're going to find a lot of the HERS requirements, as well as HERS protocols. So if you need to perform a HERS test, this is where we get that information as to how you are to do it, what are the requirements for the equipment. All of that information is found in the reference appendices. These reference materials, as well as the training slides themselves, are available for download from the file section of the training platform. Highly recommend you download those and keep them. They'll be available as a PDF, so you can keep them on your computer for access and reference later down the road. Our overall training goal is to familiarize you with the changes to the 2019 Building Energy Efficiency Standards. So in this training, we're going to cover the changes under 2019 to the following HERS features. So we'll start off looking at building air leakage, which is our blower door test. We'll then move into duct leakage, airflow and fan efficacy, HSPF, heating seasonal performance factor, and heat pump capacity, mechanical ventilation, whole house fans. Now whole house fans is an entirely new HERS verification. So we're going to look at that briefly, and then you'll be required to complete an additional training module for that one. Then we'll look at water heating distribution and finish it off with QII. The 2019 Energy Code is going to be effective on any permit applied for on January 1st, 2020 or thereafter. So now that permit does not have to be issued by that date. Just the applicant has to have submitted for that permit. So you could submit on December 31st, and you would, with the permits granted sometime in January, it'll still be granted under the 2016 code. So any permit that's applied for on or after January 1st will need to comply with the 2019 Energy Code. Now, because of that, we will see some overlap, especially in residential new construction. Oftentimes, they will pull a fair amount of permits for those projects in November and December so that they can continue to build under the 2016 code. So we'll see those still, a year or more after the 2019 code goes into effect. But where we'll see the most immediate change is in the HVAC alterations area, because those permits are not pulled out in advance. So we would expect to see 2016 permits, through January. After that, it's going to be unlikely that you're going to see many HVAC alterations permits for 2016 any longer. So you'll be transitioning over to the 2019 code. So let's take a look at the changes that we saw for building air leakage or blower door testing. The 2019 Energy Code simplifies the options available to choose from by reducing them from 3 to 1. So previously we had the single point, the repeated single point, and the multi-point test, with those having the option to do either a manual or digital meter. We've now reduced that down to just one, and remaining is the most commonly used method of a single point test, again using either a manual or digital meter. However, most of you are on digital meters at this point. There's not many manual meters left out there. Other than that, all other requirements and procedures remain the same as what we had under 2016. So all they did was reduce the options that you had to choose from. So now you're going to be doing that single point test, which is likely what you were doing anyways, using either that manual or digital meter. Next, let's look at the changes to duct leakage testing. The 2019 Energy Code adds procedures to account for small duct high velocity systems. Now we're going to see these in a couple of different areas. So we're going to see it in duct leakage, we're going to see it in airflow, fan watt draw, the airflow requirements for refrigerant charge. So they kind of peppered these throughout the different ones where they would apply. So these small duct high velocity systems, you're going to use a little bit different value just because of their design. And we'll talk about that here a little bit in a second. So for duct leakage, when you are going to determine the nominal air handler airflow, you will use a value of 250 CFM per ton for these small duct high velocity systems in place of the usual 400 CFM per ton. So if you're still doing just your traditional duct systems, it's going to remain, you're going to use 400 CFM per ton. It's only when you have these small duct high velocity systems that you will use 250 CFM per ton for that calculation. Now, these small duct high velocity systems are usually installed in existing buildings where traditional size ducts cannot be run due to size constraints. Supply ducts for small duct high velocity systems are typically 2 to 2.5 inches in diameter. Now that's in comparison to a standard duct system where you're going to see 4 to 10 inches in diameter for your supply ducts. Sometimes you'll see them a little outside of that, but for residential construction, that's your typical. So you can see where these small duct high velocity systems could come into play. So not unlike a traditional system, a small duct high velocity system contains a blower and an indoor coil combination. Now this is where it gets a little bit different. This combination is designed for and produces at least 1.2 inches of external static pressure when operated at the certified air volume rate of 220 to 350 CFM per rated ton of cooling. And when it's applied in the field, uses high velocity room outlets generally greater than 1,000 feet per minute that have less than 6 square inches of free area. So again, your typical has larger supply registers with lower velocities, where these ones, because you're restricted to the size of your ducts, you're going to have small outlets and the air is going to be moving much more quickly out of it, hence the name small duct high velocity. For altered space conditioning systems, we see some new requirements when you have duct system components that are located in a garage space. So when a new or replacement space conditioning duct system, air handling unit, cooling or heating coils, or plenums are located in a garage space, compliance with either items 1 or 2 below is required. So this is pretty much any part of that HVAC system that has air moving through it. If any of that is located in a garage space, then it needs to comply with these requirements. And so these requirements are that the duct leakage shall be less than or equal to 6% of the system air handler airflow. If you cannot achieve that 6% leakage rate, then you will go and use the smoke test to verify that all leaks that are located in the garage space are sealed and verified through a visual inspection. So this is not much different than what we see for your typical altered space conditioning system. For that, you have a leakage rate of 15%. If you can't hit 15%, then you can do the same smoke test to make sure all accessible leaks are sealed. This one's just slightly different where we have 6% and you're trying to seal the accessible leaks located in the garage space. Now you may ask, well, why are we concerned about the garage space? Well, because this is where we see a lot of contaminants that are outside of the home. If the person does park the car in the garage and they start it up to warm it up on a cold morning, you're going to have all that carbon monoxide in the garage. If the system's not running and you have a negative pressure in the home, it can draw those contaminants through any of the supply side or return side leaks. If you have return leakage, it can draw those in while the system's running and distribute them into the house. Also, a lot of times you'll have chemicals in the garage, paint thinners and gasoline, things along of those nature. Again, those can get drawn into the home. So what they're trying to do is keep a good separation between the living space and the garage space, where there are going to be additional contaminants that we don't want to allow to get into the home itself. Now let's move into airflow and fan efficacy, or fan watt draw. So a quick summary of the overall changes was that we saw changes to the fan efficacy requirements, so the watts per CFM requirements. We see values that were added for small duct high velocity systems and added requirements for central fan ventilation cooling systems. Let's start by taking a look at the fan efficacy changes. So the fan efficacy requirements were lowered from 0.58 watts per CFM to 0.45 for gas furnace air handling units. The value will remain 0.58 for non-gas furnaces. Now this is going to apply to both single zone and zonally controlled systems. And then central fan integrated ventilation systems must also comply. So this is kind of across the board. If you have a gas furnace, you're going to need to comply with the 0.45 watts per CFM rating. For small duct high velocity systems, because those are completely different from the traditional systems, those will need to comply with a 0.62 watt per CFM requirement. On the airflow side, we only see changes to small duct high velocity systems, and those systems must achieve an airflow of 250 CFM per ton or greater. And now this also applies when verifying airflow as part of the refrigerant charge verification. So your standard airflow values that you're looking for is either 300 or 350 CFM per ton, depending on which verification it's applying to. For these small duct high velocity systems, it's going to be just the same value, 250 CFM per ton, regardless of whether it's for airflow verification or refrigerant charge verification. When a central fan ventilation cooling system is taken as a performance credit, these systems may require HERS verification of the system airflow rate and fan efficacy at ventilation speed. So what does that mean? So with this being a performance credit, you're only going to see this on the PERFO 1. So you're going to need to look at that Title 24 document. If it lists that they took credit for a central fan ventilation cooling system, then they're going to want to verify that the airflow and fan watt draw are within compliance with this system when it's running. Because it is a ventilation cooling system, it's going to operate likely at a different speed than it would under regular cooling when it's connected to a condensing unit. So you're going to need to verify this system, and you may have to do two verifications, one for the cooling system where it has a standard AC, and then one for this central fan ventilation cooling system. You're going to use the thermostat, to get this running in ventilation speed, and then you're going to measure your airflow, and you're going to measure the watts per CFM. Now you're going to find your targets. There are going to be default targets, but you're going to want to look at that Title 24 document. It's going to list what the target values are. Typically it's going to be 350 CFM for the airflow and 0.45 for the fan watt draw. But again, you want to verify that with the Title 24 documents so that you're measuring these correctly. The procedures are the same. The equipment that you're allowed to use is the same. It's just that you'll be measuring this one at ventilation speed rather than high fan speed for cooling. So under the 2019 standards, we're going to see two items that were added to the overall efficiency verification. So you're used to the typical SEER and EER verification, but we've now added the HSPF, or heating seasonal performance factor, and heat pump capacity. So both of these are going to be heat pump related, but they tie in very nicely to the EER and SEER verification procedures. When installation of specific matched system equipment is necessary for compliance with requirements for higher than minimum values for system HSPF, or verification of the installed heat pump capacity is required, the installed heat pump equipment shall be verified using the same procedure as EER and SEER verification. So for those of you that are familiar with this, you're going to be utilizing the AHRI database. You're going to look up the equipment just like you would for EER and SEER verification, only this time you're going to be collecting the data for HSPF or the heat pump system capacity. So both of those values are going to be found in AHRI, just like what we see for EER and SEER, and then you're going to compare those targets to the values that were modeled on the PRF 01 document. Now for the rated heat pump capacity, it's going to be a little bit different. HSPF, very straightforward. It's a single value, just like what you'd see for EER and SEER. On the rated heat pump capacity side, there's going to be up to two values that you would need to collect. So once you look this up in the AHRI, you're going to record the system's rated heating capacity at 47 degrees Fahrenheit and 17 degrees Fahrenheit if they are published by the product directory. Now you're almost always going to see the 47 degrees Fahrenheit. What you won't always see is the 17 degrees Fahrenheit, and that's where the if published language comes from. Now if the installed system rated heating capacities at 47 and 17 degrees Fahrenheit are equal to or greater than the values specified on the certificate of compliance, then the system complies. If the product directory does not publish capacity ratings at 17 degrees, then compliance with capacity at 17 degrees Fahrenheit is not required. So there's your caveat. So you're always going to be verifying at 47 degrees. That value needs to be equal to or greater than what was modeled on the CF1R. If the value for 17 degrees is there, then it must also be equal to or greater than. But if the value is not present for 17 degrees Fahrenheit, then you just ignore that part of it, and as long as it passes at 47 degrees, then it would be considered an overall pass. Now let's take a look at the changes for mechanical ventilation. With the adoption of ASHRAE 62.2-2016 comes a few changes to this verification. So this was part of the adoption of 2019, is that they updated to ASHRAE 62.2 2016. So we're going to see some higher ventilation rates for single family units. Doesn't really affect you as the HERS rater. You're still going to be doing those verifications as you normally would, but you may see some higher rates for your targets. One of the changes that you will see and will affect you is that blower door testing will be required for attached single family and multifamily dwellings. Now this blower door testing is separate from the infiltration reduction compliance credit, and it will be documented on the CF3R MEC 24. So the typical blower door test is on the CF3R ENV 20, where this one is tied, the MEC 24 is tied to the MEC 27, which is your mechanical ventilation document. So as you start filling it out, if it's indicated that it is an attached dwelling, then as part of that document, it's going to then also trigger and require that you complete the MEC 24, which will need to be populated with your blower door testing results. Now the reasoning behind this is whenever you have an attached dwelling and you have either an exhaust or supply ventilation system, you're going to create pressure differences between the attached dwellings. By doing this, you can either draw in contaminants from the attached dwelling, or you can push contaminants from the dwelling you're in into the other one. So what they want to do is they want to verify that the walls that separate these two dwellings are as airtight as possible, so that you don't have an exchange of indoor air or contaminants from one dwelling to the next. So you're testing for a detached, your standard single family detached. You will not need to do blower door testing. It's only for attached systems that have either exhaust or supply mechanical ventilation systems. The test procedures for the blower door test is the same as what you would do for a normal blower door test. It's just going to be documented on a separate form than what you're used to for those blower door tests. The other thing that we're going to see that's going to affect you is that you're now going to be required to verify the kitchen range hood. And we'll go through the details of that here next. The code has for many years identified minimum rates for what we call local mechanical ventilation. So these are going to be your kitchen range hood, which we're going to talk about today, but it also talks about those exhaust or ventilation fans that are found in bathrooms, laundry rooms, areas where you're going to find other types of contaminants. So specifically, we're going to look at the kitchen range hood. So what is a range hood? This is a device, it's a fan of some sort that is going to be installed over the cooking surface. So you're going to have either a standalone cooktop that has natural gas or propane burners on it. It could be an electric cooktop, or it could be a cooktop oven combination where they're both a single unit. You have the oven below with a cooktop above it. All of these will produce some type of contaminant during the cooking process, whether it's a result of the combustion for the natural gas and propane cooktops, or it's just the production of smoke and or excess moisture. If you're boiling water, you're going to have steam coming off of it. All these items we want to get out of the house and not allowed to be to remain within the house. So these hood ranges are going to be above that. They may be a standalone, or they may be incorporated into a microwave oven that's installed above, and you'll have both of those. Regardless of the type of range hood, it is going to need to exhaust to the outside. They do make recirculating range hoods where it takes the air and just essentially runs it through a metal filter and then just blows it right back into your face. Those really do nothing. They serve no purpose, and those are not allowed under the 2019 code, and they weren't allowed under 2016 either. But we're looking for these to be vented to the outdoors, and they're going to need to achieve not only a minimum CFM rating. As you can see here, we've got 100 CFM for your standard vented range hood, which is what we're looking at. We're not really concerned with the other exhaust fans. And then we're going to be looking for a sound rating. So they need to be no more than 3 sones, equal to or less than 3 sones. And this is going to be when it's measured at the working speed of 100 CFM. Now, some of these range hoods, they can go up to 400 CFM for these big ones, and those are exempt from this sound rating. They're going to be, but they do need to comply when it is measured at the working speed of 100 CFM, which would be a low or a medium on that 400 CFM fan. So we're not going to be actually measuring the airflow. We're simply going to be verifying the make and model that's installed to ensure that it meets these requirements, and we'll talk about how we do that next. So your verification as a HERS rater shall utilize certified rating data from the Home Ventilating Institute Certified Home Ventilating Products Directory, or another directory of certified product performance ratings approved by the Energy Commission for determining compliance. So what that says is that we've got this product directory, very similar to what you're used to seeing with the EER and SEER verification, where we go to AHRI, we look up the equipment, and we verify the ratings for that equipment. We're doing the same thing here. So currently there is only one product directory that is approved by the Energy Commission, and they will allow, if another directory submits their directory for for approval and it gets approved, and there would be another one that we could add to the list. But currently there is just the one, and this is the web address where you will find that, hvi.org, prod directory index.cfm. So you'll go here and you will look up the make and model number for the equipment you're looking for, and you're going to then confirm that it meets the requirements for that particular type of equipment. So when you're out in the field, your verification procedure will consist of the visual inspection of the installed kitchen range hood and to verify and record the following information for input on the CF3R MEC 32. So that MEC 32, that's a new document for us, but you're going to need to collect this information to populate that document so you can get it complete. So when you go out, you're going to need to look at the range hood itself, and you need to collect the name and the model number. They're all going to have a tag on them. Usually it's up underneath somewhere, so it's kind of out of the way. You're going to need to get the name and the model number so that you can look that up in the HVI directory. Next, you're going to look it up and make sure that it is listed in the HVI directory. If it's not, then it is not in compliance. It has to be rated and in that directory. So you're going to look it up, make sure that it's there. And then from the directory, you're going to collect the rated airflow as well as the sound rating values. And those will also need to go on to the MEC 32. So you're going to have the make, the model, and the values for the airflow and sound rating, and all of those will go on to the MEC 32. If the value for the rated airflow given in the directory is greater than or equal to the airflow requirements specified in the standards, which typically we're going to see it as 100 CFM, and if the value for the SON rating given in the directory is less than or equal to the SON rating requirements specified in the standards, which was 3 SONs, then the kitchen range hood complies. Otherwise, the kitchen range hood does not comply. So it's a very easy verification. You're just going to go get make model numbers off of the flow hood, look them up in the directory, and as long as those values are within spec for the requirements and the standards, then it's going to be a pass. So very easy verification. As I mentioned near the beginning of this training, whole house fans is an entirely new HERS verification for 2019. So when a whole house fan is used in the performance compliance calculations, it may require HERS verification of the airflow rate and fan efficacy. So this is a fairly long process. So instead of including it in this training itself, you'll be required to complete the whole house fan training module as part of this update course. So once you complete this training video, the whole house fan module will be next. You will need to complete that as part of the overall 2019 update training. So now let's take a look at water heating. So the 2019 Energy Code removes the compact distribution credit from HERS verification, but adds an expanded HERS verified credit. So the compact distribution credit doesn't go away, it's just no longer HERS verified. What they did was they kind of expanded on this credit, and that's why they call it the expanded HERS credit. That is what is going to be HERS verified. So in order for the system to meet the compact hot water distribution system expanded credit eligibility requirements, the requirements for the compact hot water distribution credit must be met. So you can take the compact distribution credit as a standalone, or if you want to take the expanded credit, then they would need to first comply with the compact distribution credit before they can then comply with the expanded credit. So as I mentioned, the verification of just the compact hot water distribution system is not part of your verification. That's all going to be taken care of in plan check. What you will be doing is verifying these 4 items if they are applicable. So we're going to verify that no hot water piping larger than 1 inch diameter is present. You're going to measure and verify that the length of 1-inch diameter piping that is present is limited to 8 feet or less. For 2- and 3-story buildings, they cannot have the hot water distribution piping in the attic unless the hot water heater is also located in the attic. So typically these water heaters are going to be on the ground floor, oftentimes near the garage. And so what they don't want is to have hot water piping that runs from that ground floor all the way up into the attic and then back down into either the 2nd story or, even worse, all the way down into the 1st story. So that makes for a very long run of piping. And with this being a compact distribution system credit, they want the piping as short as possible. So it will need to remain on the ground floor and be distributed through the floor in between stories and not all the way into the attic. And then if there is an eligible recirculating system installed, it must be a HERS verified demand recirculation with a manual control system. So oftentimes you're going to have 2 of these items that you're not going to verify. If it's a single story and there's no recirc system, then you're just going to be looking for that 1-inch diameter piping, making sure there's nothing more than 1 inch, and any 1 inch that is there, that it's 8 feet or less. It's only when you get into these 2- and 2-story buildings, or if there's a recirc system, that you would have to do these additional. If there is a recirc system and it's HERS verified, then you're going to be doing that as part of the standard recirc system verification that we have there. Is just a prerequisite for this credit, so it will show up on the Title 24 as well. Drain water heat recovery system. So drain water heat recovery, or DWHR, is a technology that captures shower waste heat from the drain line. DWHR devices are counterflow heat exchangers with cold water entering the building on one side of the device and hot drain water exiting the building on the other. A DHWR device uses that reclaimed heat to preheat potable water that is then delivered either to the shower or to the water heater. The device can be installed in either an equal flow configuration or an unequal flow configuration. Equal flow means that the preheated water being routed to both the water heater and the shower. An unequal flow is where the preheated water is directed to either the water heater or the shower. So those are the 2 options that we have. The energy harvested from a DWHR device is maximized in an equal flow configuration. So we want that preheated water going to both the water heater as well as the water going into the shower. They are sold in both vertical design configurations and in horizontal configurations. And so here we have 3 examples, one of the equal flow and then the 2 options for the unequal flow, where it goes either to either the water heater or to the shower itself. So the picture on the left-hand side there, that is our equal flow. So you can see the gray line is the water that's leaving the shower. So hot water, you use it, it starts going down the drain. That water's going to be warm or hot. It's going to pass through this heat exchanger and then go out to the sewer system as normal. The blue line is then the cold water coming in from outside the house. It's trying to make its way to the water heater, and so this cold water is going to pass through this heat exchanger, and it's going to be preheated by the waste heat that's flowing out from the other side. So you're going to get that exchange of heat from the drain water into the fresh supply. Now these are not mixing, they're just going on opposite sides of this heat exchanger. So in the equal flow, we're going to get that cold water, or that preheated cold water, is going to go into both the water heater, which is going to make the water heater work less because the water is going to be a little bit warmer going in, which means that it requires less energy to heat that water up. And then as well, it's going to be going up to the shower. So instead of being able to turn on just the cold water and having really cold water come out, it's going to be preheated as well. So you're going to need less hot water from the water heater to get the same temperature within that shower. Now the one in the middle there, same concept. You have your gray line, which is your drain going out, passing through the heat exchanger. And now in this one, we have 2 cold water lines. the cold water line will split off, and one of the runs will go through the heat exchanger, get preheated, and go into the water heater, which does help because now the water heater doesn't have to work quite as hard to heat up the water, but it's going to be sending cold water up to that shower. So we're still going to need just as much hot water to get the same temperature as if we had no DWHR system installed. So it makes the water heater a little more efficient, but you're still needing to use just as much hot water to get that same temperature. And then the one on the right hand side there, same basic layout. Again, you have two cold water lines coming in. One of those cold water lines is going right to that water heater, dumping cold water into it, so it's going to have to work just like a regular water heater to heat that water up to get it the temperature that you need. But at the shower itself, you're now getting preheated water with the hot water from the shower, so you don't need as much of that hot water from the water heater to get the desired temperature. So they each have their benefits, but again, as you can see, you'll get the most benefit out of that equal flow system. So for your inspection, you will need to verify the following requirements. The make, model, and CSA B55.1 or IAPMO IGC 346-2017 rated effectiveness of the DWHR unit, and these will need to match the compliance documents. So again, when they do the performance modeling, they're going to create that CF1R perf, and that is going to have the required effectiveness rates listed on there, so you need to make sure that those match up, and then you're going to get the make and model numbers so that you can confirm that those are the values that are associated with it. Next, the DWHR units shall also be verified as a model certified to the Energy Commission as qualified for credit as a DWHR unit. And this is, they will keep a list of all of the approved models, and you'll just need to look on that list to verify that it is that this particular make and model of unit is present on that list. And then the installation configuration and the percent of served shower fixtures shall match the compliance documents. So again, it's either that equal flow or unequal flow, and then depending on how many showers are on the home, they may take credit for installing one of these on just a single shower or in multiple showers. If they have 3 bathrooms and each bathroom has a shower, then they may take credit for these devices on all 3 of those showers. So you need to make sure that it matches the configuration and the number of shower fixtures that need to have that device installed. For a water heating system serving a single dwelling, the DWHR system shall, at minimum, recover heat from the master bathroom shower and must at least transfer that heat either back to all the respective showers or the water heater. So that would be an unequal flow. So that's the minimum, is to have that unequal flow. For a central water heating system serving multiple dwellings, the DWHR system shall, at the minimum, recover heat from half the showers located above the first floor and must at least transfer that heat either back to all the respective showers or the water heater. So again, the minimums for these, whether it's single dwelling or a central water heating system on multiple dwellings, is the unequal flow method, and you're going to be transferring that heat either to the other respective showers in the home for single, or at least half of them in a multifamily scenario, or just back to that water heater. The DWHR unit shall be installed within 1 degree of the rated slope. Slopes DWHR shall have a minimum lengthwise slope of 1 degree, and the lateral level tolerance shall be within plus or minus 1 degree. So these devices are intended to be installed with some slope so that the water will drain through it at a steady rate, and that rate is how they calculate how efficient that unit's going to be. If it's got too much slope on it, that hot water is going to flow through it too quickly, and you're not going to get enough heat transfer through it for it to meet its rated effectiveness. So what you're going to need to have a digital level so that you can go up there and you can check that it is installed within 1 degree of the rated slope, and that would be the manufacturer will provide that, so you can get that information from the installing contractor. And so you're going to check that to make sure. And so you have a plus or minus 1 degree tolerance that is allowed. So let's say it's supposed to be installed at 3 degrees. If it's between 2 and 4 degrees, then that would be acceptable. And last, let's look at quality insulation installation, or QII. So now there's no changes to the verification for you as a HERS rater. Some of those items were clarified somewhat within the reference appendices, but overall the verification is going to remain the same. What does change for 2019 is that QII is now a prescriptive requirement for all single-family buildings in all climate zones and multifamily buildings in all climate zones except climate zone 7. So what does that mean for you? You're going to be seeing QII a lot more. And the reason for that is, with it being a prescriptive requirement, yeah, if you do the performance model, you can uncheck the box for QII and you can model it without it, but it is a severe penalty to do so. So it's going to be more cost effective to comply with QII than it is to take it off of the compliance documents and replace it with other HERS verifications and non-HERS improvements to the building itself. So as 2019 rolls through and more builders are having to comply with it, you're going to be seeing this a lot more. What you're going to want to do as a HERS rater, especially if you're not working with a production builder, you'll still need to do it working with a production builder, but more so for those that are working with those that build single family homes. The custom homes where they're building just one at a time on a lot that's here and there. These people are not likely going to know what QII is all about. They're not going to know when you need to get out as an inspector to do your HERS verification. So as soon as you can, you'll want to contact any of those contractors that you work with, any of those builders. Make sure that they are aware that QII is a prescriptive requirement and they're likely going to be seeing it on their projects moving forward, and that when that credit is taken and it is required, that you need to get out at the rough stage of construction so that you can do your QII inspection. If you are not brought into the project early enough to where you can verify QII at the rough stage, and they call you in at the normal time at the end of the project, all the drywall's installed, well, guess what? They are going to be in a lot of trouble, because now you cannot verify QII at this stage. They're going to have to rerun the Title 24 calcs. They're going to have to remove QII as a HERS verified measure, and they're going to have to try and get that home to comply without QII, which is going to be near impossible. So it's going to be a very costly and time-consuming experience for that builder if they're not aware of this. So get out there, get the word out as much as you can, and your builders will thank you for bringing them up to speed with what's going on so they can comply with this, as well as not only the timing issue, but what does it mean to comply with QII, so that they're aware of it and they can make these preparations before they get into construction and find out that, oh no, I didn't do this right, and I've got to fix all these things. Be proactive with it. Get out there and talk to your contractors and make sure that they know. If you need any assistance with that, we'd be more than happy to work with you to provide that training to these builders and these contractors, so that we know that everybody's on page with QII. Now, should you feel the need to brush up on any of the HERS verifications that you were trained on a while ago, but haven't done for some time just because it's outside of the normal scope of work for you, we have made all of the training materials for the 2019 code available for free through our Cheers YouTube page. Now, these videos that are free to view will not count towards any certification that you may want. If you want to obtain additional certifications, you will need to go through our training site to do that. And again, reach out to us, give us a call, or go to cheers.org/training to see or access our training page. But if these are just, you want to brush up on them, you already have the certification, but you haven't done a blower door in a long time, and you know you're going to need to do these now for the mechanical ventilation, and you want to watch that training, or anything along those lines, those are available. So we've provided you with a link here to the YouTube playlist for the 2019 Raider training materials. You can also find the link to our main YouTube page through the cheers.org/training page. We have a link there to the main page where we have all of our 2016 materials. We also have all of our HERS registry training materials, how to do different things within the registry itself and fill out various forms. So a lot of good information available for you there. Should you have questions, please don't hesitate to reach out to us. We'd be more than happy to answer those questions and provide any guidance that you might need. You can reach us through either email or phone call. As always, I'll be more than happy to speak with you and get those questions answered for you. Now, as I mentioned earlier, the whole house fan training module, you'll still need to complete that in order to complete the overall update course. This is just part one of 2 parts. So once you complete this, go ahead and complete that. We'll get a notification from the training platform that you've completed both modules, and we will then update our records to show that you are updated for 2019. Now this does only cover the certifications that you currently hold. If you are an alterations only rater, you will still only be certified as an alterations rater for 2019. If you want to upgrade your certifications and get your new construction as well as possibly your non-residential, go ahead and reach out to us. You will need to go through some additional training to do that, but that will then allow you to do more work within the industry and not be limited to just HVAC alterations. If you have all the certifications, then this will update your certifications for everything. So that will conclude part 1 of 2 of your 2019 update course. If you have any questions, comments, concerns, go ahead and reach out to us, and we'd be more than happy to hear from you.